All right, so after we've made our scatter plot and we look at the scatter plot and we think, okay, maybe there's a linear relationship, I don't see a definite curve, we're going to go ahead and calculate a correlation coefficient. So the correlation coefficient is a numerical measure of the strength and the direction of a linear relationship between two variables. So this correlation coefficient that we're going to look at can only be used to measure the strength of a linear relationship. If there's some sort of curve, it's not going to tell you how strong that curve is. Okay, it's only going to tell you how strong the linear relationship is. So here we have the equation for the linear relationship. We are not going to do anything with this equation by hand. There it is. You can see all of its beauty and craziness on how to calculate this value. The important thing here is that the correlation coefficient is notated with a lowercase r. We are going to let technology do all of these calculations for us. So the properties of this r value, this correlation coefficient, it is always between -1 and +1. If r is +1, then you have a perfect positive linear relationship, meaning the dots follow a straight line. There's not a single dot that isn't on that straight positive line. If your correlation coefficient is -1, then you have a perfect negative linear relationship. So again, it's perfect. Every single dot is on that line. The closer we are to +1 and -1, the more evidence we have that a linear relationship exists. So we want to get values that are close to +1 and -1. What we don't want to see are values close to 0. Because if your r value is close to 0, then that suggests there is little or no relationship between the variables. And finally, our correlation coefficient will be affected if we have any outliers. So what we're going to do now is I have this little chart that we're going to look at, which gives us kind of an in general rule of thumb for looking at correlation coefficients. So the correlation coefficient spans from -1 to +1, and then 0 is going to be in the middle of that. So -1 is a perfect negative linear relationship. 0 means there is no linear relationship. And +1 is a perfect positive linear relationship. So then we're going to break down the values in between. So I'm going to start on the positive side and work backwards to the -1. So if I have a correlation coefficient between 0.7 and 1, this area in here, that is a strong positive linear relationship. And that's what we want to have when we're looking at these correlation coefficients. We want to have a strong relationship. Doesn't necessarily have to be positive, but we want it to be strong. Okay, that's going to be the best way to deal, or the best situation for creating these models. Then from 0.3 to 0.7, this is a moderate positive linear relationship. So it's not bad, but it's not quite as strong as other ones. So we could still create a model using a moderate positive, but we just kind of have to keep in mind, like, okay, it may not be perfect because it was only a moderate relationship that I saw. And then from 0 to 0.3, this is a weak positive linear relationship. And we do not typically want to create a linear model off of anything that falls in this range. This is where we would then take the next step and say, okay, well, maybe there was a curve in the data, or maybe I saw some clustering in the data that would suggest that maybe a different model besides a linear one is a better fit. So then the negative side is just the mirror image of this. So from 0 up to negative 0.3, that's where we have our weak negative linear relationship. And then from negative 0.3 to negative 0.7, this range in here, this gives us a moderate negative linear relationship. And then from negative 0.7 to negative 1, that is going to be a strong negative linear relationship. So again, we really want to see relationships that are in these two purple areas, strong negative or strong positive. If you have moderate, the green sections, that's okay. You can still work with that, but you just have to be a little more hesitant about drawing conclusions from that. And then finally, our weak negative and our weak positives, the orange area, if we get something in here, we really don't want to create a linear model from this. So then down here, I just have a few examples of what the scatter plot might look like given the correlation coefficient. So we see a perfect negative, a strong negative. So see on the strong negative, I could still draw a line through these dots, but it's not going to be perfect like I could with the negative one. And then we have a moderate negative. So again, I can definitely see how a line might fit through there, but it's a little harder. Weak relationship, I can't find anything to draw a line through this one. Then we have a moderate positive. So here again, I could maybe draw the line there, and that might fit pretty well. A strong positive, definitely, oh, this is going to go right through there. I'm not going to go through every single dot though. And then our perfect positive, if I could draw a straight line, I could draw a straight line and hit every single dot. That's not bad for a straight line for me. Okay, so this is kind of what the scatter plots look like based on different correlation coefficients. So the correlation coefficient, it's going to be calculated using technology. We're going to get a single number, and based on that number, we're going to determine what type